The Let's Talk Chemistry with Pastor Dan. We're looking at something called the empirical formula. Now, an empirical formula is defined as a formula compound in its simplest form. Easiest way to show this to you, it's a compound like H2O2. If you don't know what that is, that's hydrogen peroxide. It looks an awful lot like water, but it's not. Don't drink it. It's toxic. All right, now, disinfectant. All right, now we have two hydrogens and two oxygens there. So if we were to simplify that down, we would get, think Christmas here, ho, ho, ho. HO would be the simplest form and without any kind of variation that way. All right, so process for doing empirical formula. What we're going to do here is we're going to convert the units to grams. Then we're going to convert to moles because that way it's a unit of chemical reactions. Then we're going to divide by the smallest number. The reason we do that is so it's a whole number ratio. And then we multiply till all numbers are whole numbers. And by that whole numbers, we need that first decimal has to either be a 0 or a 9. All right, so let's show me talking about. Let's do a simple one here. Find the empirical formula if you have 69.94% iron and 30.06% oxygen. So we take our given, and we're going to assume there's 100 grams of sample. Now, if I assume there's 100 grams sample, that means that 69.94 grams of that 100 is iron. And that means 30.06 grams of that sample is oxygen. Now, it's going to be O and not O2. We're not doing diatomics here because of the fact that it's individual elements. We put that over 1 here so that we have a value to work with. All right, now we're going to convert to moles. We converted to grams first, now we convert to moles. So for iron, in the periodic chart, 1 mole is 56 grams. For sulfur, oxygen rather, 1 mole is 16 grams. Now we multiply through, we have 4 sig figs. We take 69.94, divide by 56 to 4 sig figs. We get 1.249 moles of iron. Now take 30.046, again we have 4 sig figs, divide by 16, we get 1.879 moles. Now those are moles, but they're not whole number ratios. So we got to compare. I have 1.249 moles of iron and 1.879 moles of oxygen. Which one is the smallest to get a whole number ratio? That would be the iron. So we're going to divide both sides by 1.249 mole, just mole, not iron. And then we divide by 1.249 mole there. When I do the first one, it's real simple. I get 1.000 irons, and I get 1.504 oxygen. Now, is this first decimal a 0.9? Yes, that's close enough. Is this one close enough? No. So we're going to have to do that next to last step, multiply until you get the whole number. So we're going to multiply by 2. If I multiply by 2, I get 3.008. That's close enough. That first decimal is a 0 or 9, so that's close enough whole number. So I have 2 irons, 3 oxygens. Formula is Fe2O3. All right, great. Let's try another one. To identify the empirical formula, if you have a substance composed of 50.00% silver and 24.07% chromium and 25.93% oxygen. Again, we're going to convert to grams. So we have 50.00 grams of silver, 24.07 grams of chromium, 25.93 grams of oxygen. We do that assuming we have 100 grams of sample. Now convert these all to moles. So we're looking at periodic chart, find the grams for silver, grams for chromium, grams for oxygen. If you look it up, you should get 108 grams for silver is 1 mole. We multiply that through, we get 0.4630 moles of silver. Okay, chromium, 52 grams for the periodic chart. Take your calculator, take 24.07, divide by 52, got 4 sig figs. I get 0.4629 moles of chromium. And lastly, oxygen, 1 mole of oxygen is 16 grams. Again, it's not diatomic here. We're going to get 1.621 moles of oxygen. Now, with the smallest number ratio, it's going to divide by the smallest number. So that's 0.4629 moles. Divide them all by 0.46. So we're going to get 1.000 silver, 1.000 chromium, and 3.502. Again, that's not a 0.9, so that's not close enough. We're going to have to multiply by 2. That gives us close enough, 0.9. So we do it all by 2. So we have 2 silvers, 2 chromiums, 7 oxygen. Formula is Ag2Cr2O7. Can you remember how to name that? Ag is silver, Cr2O7, that's dichromate. That's one of those polyatomics you're supposed to know. Remember, do we know the oxidation of silver? Yes, we do. So that is silver dichromate. All right, awesome. Let's try another one. Okay, this time I want you to calculate the empirical formula of a compound with getting more of them now. We got 4 elements to go through. So So we take them all over grams, assuming we have a 100 gram sample, put them all over 1, convert them all to moles. So look at the periodic chart, define the moles for carbon, hydrogen, nitrogen, oxygen. Stop the video, do that. You should get 12 grams of carbon, 1 gram of hydrogen, 14 grams of nitrogen, and 16 grams. Now stop the video, do the math for carbon, hydrogen, nitrogen, oxygen. Okay? You should get 1.689 moles of carbon, 2.70 moles of hydrogen, 2.027 moles of nitrogen, 3.041 moles. Now we get to step with a whole number ratio. So of these 4, which is the smallest number, moles with carbon is the smallest number, so we're going to divide them all by 1.689, so we get 1.000 carbon, 1.60 hydrogen, 1.20 nitrogen, and 1.800 oxygen. Now, we definitely aren't close to a 0 or 9 for each of those, so we got to start multiplying. Let's take the first one. Let's try 2. 2 doesn't work. That's 3.2. Doesn't work. Let's try 3. That's 4.8. Nope. Try 4. That's 6.4. Nope. 5. Yes, 5 works. I get 8 hydrogens. So we'll do 5 for all of them. If I do 5 for them, I get 5 carbons, 6 nitrogens, and 9 oxygens. Formula is C5H8N6O9. That's my answer. All right, let's try one now. This one, I want you to figure out a different process, a little bit different. So we do the same thing we've done so far. Convert to grams. So there we are. Put them over 1. Convert to moles. Compare that chart. Find the moles, grams for moles of each of those. You should get 24 for magnesium, 19 for nitrogen, 16 for oxygen. Convert those to moles. Do that. See what you get. Should get 0.629 moles of magnesium, 1.266 moles of fluorine, 3.798 moles of oxygen. Now, smallest number, that would be that magnesium here. We're doing that again to get a whole number ratio for comparison. So we're going to divide by 0.6329 moles. That gives us 1.00 magnesium. Is that close enough? Is that last number 0.9? Yes, it is. We're good to go. Okay, so for 1.266 divided by 6.6329 moles, we get 2 point. Is that close enough? 0.9? Yes, it is. All right, and then 3.798 divided by 0.6329, we get 6.001 oxygen. Are those all close enough? Yes, they are. So formula will be MgF2O6. Now, if you put that down, that technically is right, but look at it, F2O6. We've done ionic nomenclature. Magnesium's a cation, it's a metal. F and O are nonmetals, that's a polyatomic. There's got to be something we can work out of that. Well, we got a 2 and 6. We can take a 2 out of both of those values, and we'd end with MgFO3, parentheses twice. Hopefully, remember that's magnesium fluorate. Both of those are right, but in my class, when we do that one there, this one here with the proper, I give you a bonus point. So that way, that's a bit of a help. All right, let's try one last one. Do this one on your own. Stop the video, get the answer, and at the end, we'll go over it. Okay? Here we go. All right, let's see what we got. So we should get 0.84986 moles for zinc, 0.56658 moles for phosphorus, 1.6997 moles for oxygen. Smallest number is the phosphorus there. So we divide them through, we get 1.5000 for zinc, 1 for phosphorus, 2.99. Now that's the first time we get that, but that is close enough. But this 1.5 isn't, so we're going to multiply them all by 2. So we get 3 zincs, 2 phosphoruses, and 6 oxygens. My formula is ZN3P2O6, but again, we can take a 2 and 6 out, so we get ZN3PO3 twice. Remember, that's zinc phosphite. There we go. Does that make sense? Hopefully it does. All right, we're going to practice next and go from there. All right, take care. Bye.